Hello, welcome to the second part of our sixth lesson in our fourth unit, Graphing Quadratics, in our grade 10 academic math class. So in this lesson so far, we've been introduced to the third and final form of a quadratic relation we're going to see in this unit, which is factored form. Factored form tells you a couple of things right off the bat. Just visually you can see it from this particular form. The a value, of course, which is common to all three forms of a quadratic relation, tells you not only the direction of opening, but the plot pattern. The new piece added today, or in this lesson, is that the s and t values correspond to the x-intercepts, or zeros, of this quadratic relation as you graph it. Of note is that, if we look at our first example here, which we already filled out, of note is the fact that when something in that bracket appears positive, it is actually, in this case, minus -2. Which makes it look positive, although the value in that first bracket, the s, is actually a -2, not as it appears a +2. Same thing for x minus 4. It looks like a -4, but it is actually minus +4. The reason that that is true is that the form of this quadratic already contains these negative values, or these negatives in the binomial brackets. So we have to honor that, just keeping in mind that the actual s and t values will be different than they appear in examples. Okay, let's get on to the second example we're going to work through. Let's jump right in. So for y equals -2 bracket x minus 3 close bracket open bracket x minus 1 close bracket, we are going to state a, s, and t. Now the a value, again, just hanging out front of our quadratic, that's pretty straightforward. Our a value is going to be -2. Now our s value, remember what I just said, this looks like a -3, but it is actually a +3 in that it is x minus +3, which when you take those two signs and combine them, you'll end up with a negative. So it is actually a positive value. Same thing here, looks like a -1, but it's actually minus +1. So our t value is going to be, that's a highlighter, is going to be +1 as well. So let's state a few things that we know here. Our x-intercepts, or our zeros, are not the ones found in the brackets. They are the restated s and t values, in this case +3 and +1. So I'm going to write those out as points. We have 3, 0 is one x-intercept, and 1, 0 is our second x-intercept. Now the direction of opening with a negative a value is going to be down, as we know. And we want to find the equation of the axis of symmetry in order to get the vertex. And as we know, the vertex is the one that allows us to best graph a quadratic relation. So we need to get our vertex, but as with the other example, let me start by putting the x-intercepts on there. So our two x-intercepts are going to be 3 and 1. So there's 1, 0, there's 3, 0. I'm not going to label them just yet. But I do know, visually, I can see that because this is a symmetrical shape, I know that my axis of symmetry is going to fall right between those 2 points. In essence, what I'm doing there is I'm letting my eye draw the average between those two x-intercepts. And the average, of course, would correspond to the visual line that divides our parabola into two, also called our axis of symmetry. So we have x equals 2 there. Now, what we just did visually with our eyes, we can also do algebraically by taking s and t and adding them together before dividing by 2. So recall the s and t values were 1 and 3. Dividing by 2, that's going to give us, oh, I'm going to have to get a little smaller, 4/2, which means our h value will equal 2. Which, again, we can do it visually. If that's not your jam, you can also just do it algebraically right here. Now, as you recall, now to find the coordinates of the vertex, we are going to find k by substituting our h value into the equation. Okay, so let's do that now. We know that the equation is y equals -2 x minus 1 x minus 3. I think that's what it was. Oh, I have them backwards. It doesn't really matter. Well, I guess we'll be consistent. I'll do that. So that was the 1, and sorry, that was the 3. And now we're going to substitute our 2 in there. So we have -2, 2 in for our x, 2 in for our x, and now we simplify. 2 minus 3 is -1, and 2 minus 1 is going to be 1. So we have -2 times -1 times 1. That's going to give us a k value here of 2. So our vertex then will be 2, 2. And let's put that on our graph. So over on the graph, 2, 2 is going to be our vertex. Oh, that's not the right spot. There's 2, 2 right there. Sorry about that. This lines up, right? We know that our parabola is going to be opening down, but let's explore our plot pattern here. So our plot pattern, as I continue to say, is vertically 149 every time that we go 1 out from the vertex in either direction, 2 out from the vertex in either direction, or 3 out from the vertex in either direction. And we are going to amplify that by our a value. Now our a value in this case happens to be 2, so instead of going out 1 and down 1, we're going to go out 1 and down 1 times 2, which is 2. Instead of going out 2 and down 4, we're going to go out 2 and down 4 times 2, which is 8. And instead of going out 3 and down 9, we're going to go out 3 and down 9 times 2, which is 18. So that's our plot pattern. Let's continue the plot pattern on our graph. So we already did out 1 and down 2. Those correspond to our x-intercepts. Now I want to go out 2 and down 8. So 2, 3, 4, 5, 6, 7, 8. And I'm not going to have room for 18, so I'm just going to leave it right there. Let's draw some lines on this thing, making them nice and curvy. Let's get some arrows on it and do some labeling. So our vertex is 2, 2. Our x-intercepts 3, 0, and 1, 0. Our y-intercept 0, -6, and the equation itself, so y equals -2, x minus 3, x minus 1. And that is our graph of a quadratic relation from factored form. Now the last thing I want to point out here is it's asking us to find the y-intercept for the parabola as well. Now for us, we've already found it based on our plot pattern, but there is a method algebraically to do this. And the method for doing this is to change from this form, the y equals -2, x minus 3, x minus 1. We want to change that into a form that will tell us the y-intercept, which is standard form. So the way to do this is to expand this bracket, this pair of brackets out. So I'm going to do that now. If you are asked to do this, I always recommend expanding out the binomials first before distributing the -2 into the result. So let's start by expanding out these binomials. So we're going to have -2, and then in a bracket we have x squared, and then I'm going to keep changing up colors, I guess. So we'll do then over here, that's going to be -1x. Then we do the middle terms, minus 3x, and then we do the last term, which right there, and that will give us +3. Okay, so we've expanded out our binomials. Man, I'm going to run out of room. And now I'm going to simplify by gathering together these two like terms. And now I'm going to distribute that -2 into all three, I guess I'll do it underneath, into all three terms in our bracket. Ugh, bad form here. I'm going to just jump columns, which is not great, but it is what it is, I guess. So we now have y equals, so that will give us -2x squared. Try to keep that all on the screen, plus 8x and -6. So now that we've changed over to standard form, what you'll notice is this c value corresponds to our y-intercept. So our y-intercept based on this should be 0, -6, And as we look back at the graph, what we see is indeed our y-intercept, whoops, let's get the highlighter back, our y-intercept is indeed 0, -6. So two methods for getting that. You can rely on the plot pattern. If it's not going to actually show up on your graph, of course, you can change from factored form to standard form and then use the C value to tell you the y-intercept. So that's the end of our lesson. Try the homework. If you have any questions, by all means, reach out to me via email, and I'll do my best to help you out. Otherwise, friends, we are almost done this unit on graphing quadratics. We have one more lesson, so we'll see you in lesson number 7.